Hello everybody, this is just a quick tutorial video on how we can use the excellent SpecEmu by Mark Woodmaster to trace a crash in code. This is particularly useful if you're debugging someone else's code. So if you haven't got time to kind of really step through and find out what's going on, this can be a good technique to get you quickly to the problem area. Bit of background is that Alan Turvey, my good internet friend, has been working on a new version of AGDX, version 5, and what happened was in the development it was found that when you save a game as a tap and save it as to run externally on its own, it would actually crash once loading up. Because there had been quite a few changes, considerable amount between version 4 and version 5, it was not straightforward to kind of locate where the error was. So we've done a compare of the source codes from version 4 and version 5. Everything looks okay. The changes all look good and legitimate. There wasn't anything that was jumps out. So the next step after that, I've assembled both version 5 and version 4, and what I've done is create a list file when I've done the assembly. What that list file does is creates a map of RAM and the memory address and the instruction that's currently out, but it still has all the labels in there. Very useful for debugging. So I've done that for version 4 and version 5. I've also taken saved the same game out in version 5 and 4, and they'll be the ones that we'll use to kind of detect where the error is. So the next thing we need to do, we need to get SpecEmu up, so we'll launch that. What we'll do is jump in with the version that crashes basically, so we'll load that into SpecEmu, we'll reset, we'll launch, we'll select the control 1, and we can see, there we go, we've got a crash. So what we can do is reset that again. I know the point now where this program crashes. It's after I select 1 and it draws the map, so I've got a good idea when we need to put the logging feature on. So we'll start the game again, and what I'll do now is I'll go into the debugger and I'll use this start PC trace, and I'll overwrite this file here. Do you want to overwrite? Yeah, that's fine. As soon as I close this debugger window, SpecEmu will start to log every instruction that PC is running through into the log file. So we need to be quick. So we'll close out and press 1, capture the crash. Okay, and then SpecEmu will warn us that the log file's grown to 20 meg. Do we want to continue? No, we don't. We'll finish logging. So we can go back to our logs and let's open our log file. So what this file is an output of where PC was running through in memory and the particular instruction that it was running at that particular time. So it's good for finding out where something went wrong if you get in a crash. So what we'll do, we'll scoot down, pressing page down. We can see the second column, this is the memory address, that's the T states and the instruction. So we'll keep going down until we can see something that doesn't fit in, because addresses from around 7D00 is within game code, because AGD saves from around 3200 upwards when you save a tap. So anything in that particular area, we can honestly say this is all legitimate game code. We could go back to our list and check that, but we don't need to check that far. So we'll keep scanning through. All looks like a good gig. Oh, so now as you can see here, we're running through some instructions that are all NOPs. NOPs is 0 bytes, so that means empty memory. So something's happened. So I've just scrolled up till I can see the last bit of proper code, and then we can see a call here at memory address ABFF, which jumps to 707A, and if we put that in there, 707A is 28794, and I know that, like I say, AGD games generally start off higher than that. So something in the game code is calling an instruction that doesn't exist. So why could that be? So what we'll do is we'll launch and have a look at the listing file, and then what we can do is we can jump to 707A, We can see what's there, see what it is. So as you can see at 707A, there's this instruction looks like add A32. So add A32, and then the other instruction where it was called from was 8BFF. So 8BFF, and we can see there it is actually called, so it does call it. So we'll go back. So what I can deduce is happening here is this listing is from when the editor is also in memory, and this is definitely within editor memory. So the new changes have inadvertently called a routine that only exists in editor RAM. So when you save the game out as an external tap, those particular routines no longer exist, game crashes. So that was a quick way that I used to determine a crash. Obviously this won't be that useful if you're trying to chase down different types of bugs, but this is usually a quick way to get to the crux of the matter. So I hope you find that useful, and I'll see you next time. Bye bye.